Hi, Robin. I just want to go through your worksheet and give you a few suggestions to work on as you go into the first part of the chemistry module. Question 1 looks really good. Just watch out for the spelling of fluoride, okay? So fluoride is spelled F-L-U-O-R-I-D-E. In this section here, you have the metal written before the non-metal. If you take a look at the position of vanadium on the periodic table, it is number 23. It is to the left of sulfur, which is element number 16. That means that vanadium has to go on the left-hand side of the compound formula, and sulfur should go on the right-hand side. So, for example, the formula should be V2S5. Your next one be Br5, etc. You do have the correct proportions or number of cation and anions. You just have them switched around. In question number 3, these are all things that should have Roman numerals in them. For example, if you take a look at tin, which is number 50, tin can be 2 positive or tin can be 4 positive. So we have to indicate which one of these two it is in the formula SnF2. To do that, we look at the charge of fluorine. Fluorine has a 1 negative charge, and there are 2 of them. So that means that there's 2 negative in total. That means that tin has to be 2 positive because the number of positive charges has to balance out with the negative charges in order to have an overall neutral ionic compound. So that means that in this formula here, you have to indicate that you are using the 2 positive ion by using Roman number 2. In the next question, you have the same thing. Copper is number 29 on the periodic table. Copper can be 1 positive or copper can be 2 positive. If we take a look at the formula, we have 3 parts copper and 2 parts nitrogen. Now we know that each nitrogen has a 3 negative charge when it becomes an ion. There are 3 different copper ions. Now because we have 2 nitride ions, 3 negative plus 3 negative is going to give us a 6 negative overall, which means to create a neutral ionic compound, we need 6 positive. Now, if this was copper 1, and we had 1 positive, 1 positive, 1 positive, 3 positive and 6 negative is not going to make a neutral ionic compound. However, if we have 3 of copper 2 positive, that means that 2 positive plus 2 positive plus 2 positive is going to be equal to 6 positive. So in here, you need to add the Roman numeral 2 to indicate that this substance is copper 2, not copper 1 nitrate. What I would suggest you do is go through the periodic table and highlight all the metals that have more than 1 charge. And at the bottom of your periodic table, make some kind of note to indicate that you need to include a Roman numeral in those charges. Okay. In question number 4, you had some polyatomic ions to work up. So first of all, make sure that when it asks you for formulas, make sure that you write down element symbols and the proportions rather than the name of the substance. The biggest challenges that you had were with this one right here and with this one right here. Okay. So aluminum, number 13 on the periodic table. Aluminum is 3 positive. Hydrogen phosphate is the name of a polyatomic ion. So if you take the table, you can get the table from the chemistry data tables if you still need it, and find hydrogen phosphate down on the list. The formula for hydrogen phosphate is HPO4 2 negative. This is a polyatomic ion. Whenever you use a polyatomic ion, you have to keep the formula together. You don't get to take off the H part and report the H part separately than the PO4 parts. You need to balance the overall charges. That means that I am going to need 2 parts aluminum. That's going to give me 3 positive plus 3 positive, which is going to be 6 positive. And I'm going to need 3 of the hydrogen phosphate ion in order to get 6 negative. So we have 2 negative plus 2 negative is 4 negative, plus another 2 negative is 6 negative. When you write the formula, you want to indicate how many of each ion you used, not their charge. For example, I have 2 aluminum, so that's going to be Al2. I have 1, 2, 3 hydrogen phosphate. This is a good time to review brackets. If I just put the 3 right there, it makes it look like I need 43 oxygen. It's kind of weird. I actually need 3 of the whole hydrogen phosphate ion. So I need to include that in brackets and then put the 3 there. Notice that the H is with the PO4. I have not taken the H outside of the brackets. Oops, I didn't mean to do that. Just erase this first, and then I'll go back a slide. Okay, let's look at the ammonium ion, NH4 positive, and the hydrogen phosphate ion, HPO4 2 negative. I have 1 positive and 2 negative. I need a second ammonium so that I have 1, 2 positive, which is going to balance out with 2 negative. That means that when I write out the formula, because I have more than 1 ammonium ion, I'm going to have the ammonium in brackets with a 2 after it, and then HPO4 together afterwards. I don't need any brackets in this part of the formula because I'm only using 1 of that whole group. Don't take this H off and try to combine it with this H. These things are 2 separate entities, and they will not cross over to the dark side, so to speak, to become part of an ion. We'll deal with cases that might do that in the acid-base unit of Chemistry 30. So you have a pretty good sense of proportion. It's just a couple of times here, right here, right here, right here. You're having a bit of a challenge with using the polyatomic ions. Okay, next. You're doing really well with putting the names together. You recognize here that you've got a polyatomic ion, and you use the special name for that, so that's really good. Here, here, and here, you have a metal that has more than one charge, so in the formula, you're going to have to, or so in the name, not the formula, you're going to have to indicate if it's one ion or the other. So for example, in cobalt nitrate, this should be cobalt 3, and this one, it should be mercury 1, and down here, it should be manganese 2. Next slide, you did well with this question here. You've got your prefixes and naming and how to make a compound formula correctly, so that's really good. Down in the next question here, you have the correct proportions with these ones, but I'm really curious about why you're using zeros in B, C, and D. Whenever you put a number in front of a formula such as HNO3, this multiplies everything behind by that number. So for example, if I write 2 here, what that means is that I literally have 2 of HNO3. In total, I have 2 hydrogen, I have 2 nitrogen, and I have 6 oxygen. If you write a 0 in front of a compound formula, it multiplies the compound by 0, which means you have nothing of it, because 0 times anything is 0. I think what you might be doing is writing numbers for how many things you're adding. You are writing numbers here to indicate how many molecules of substance you have. So if you write 2 HCl, that means that you have 2 of this entire thing here. Let's take a look at D as an example. You have H2O plus O2, and that's going to give you H2O2. If I do a tally chart, I have 2 hydrogen and 3 oxygen on the left, and I have 2 oxygen and 2 hydrogen on the right. In order to balance that, you're right, I'm going to need a 2 here, because then that's going to give me 2 times 2, 4 hydrogen. 2 oxygen here, plus another 2 here is going to give me 4. You're right, I'm going to need to multiply hydrogen peroxide, which is H2O2, by 2, and that gives me 4 here and 4 here. Where the error here is right here. You're writing that we need 0 oxygen. And that's not the case, because if I put 0 here, that means we have no oxygen. Instead of writing 0, we're going to write 1. Or we can leave the blank without a number, because by writing down the chemical symbol, we automatically communicate that we have 1 of that substance in the chemical formula. By writing 1 here, that means 1 times O2. So you've done good work. I can see your logic here, and I know you're getting the idea of balancing, and I'm not super freaking out or concerned that you are totally off track here, but there are just a few little things that you'll need to touch up on here. So I would like you to try B and C again. I mean, D is right here. And every once in a while, I'm going to give you a couple of equations to balance, just to keep practicing so that it becomes more automatic and you experience more confidence with this. Thank you for completing this pre-assessment, the post-assessment. If there's any other questions that I can answer, please let me know.